afternoon, everyone, and welcome to our webinar today entitled Lithium Battery Regulations and How They Affect OEMs. My name is Ed McMahon. I'm the CEO of Epic Engineered Technologies, and I'll be your presenter today. Before we get started, all of the attendees are muted, so if you have any questions, please enter them in the chat box that's on the bottom right corner of your GoToWebinar dashboard. At the end of the webinar, we'll take a few questions and answer them here as part of the webinar. And all the other questions we will make sure that we respond to in writing by the end of next week. So thank you again for attending. To start, I would take just a few moments and talk a little bit about who we are and how we got here. Epic Engineered Technologies has been in business for over 64 years with over 117 employees worldwide. We've been really at the front of innovation on many of the different products that we manufacture. Along with manufacturing battery packs, we started in business doing printed circuit boards back in the early 60s. Today, we continue to manufacture both rigid printed circuit boards and flex, along with high reliability user interface, cable assemblies, and energy efficient stands and motors. Our operations span the globe. We have manufacturing locations in the U.S., in the U.K., and a large operation in Asia. And that significant investment has helped us to help our customers be cost-effective, deliver the leading technologies, and help manage their supply chain. And our customers really they scan the range of the world's leading OEMs in all of their industries. So we've got a lot of different experiences that we bring to the table with our customer base. But today, we've got a couple of specific objectives, and that is to provide an overview of the changes in the UN 38.3 testing requirements that will go into effect January 2017. They were actually finalized at the end of 2015, and they're going to be put into effect here at the end of this year. And then also the changes to the IATA dangerous good regulations, specifically on lithium batteries, that we're already living with as they went into effect in April 2016 of this year. So just to start off, I know that many of you probably know what all this stuff is, but I wanted to make sure we just kind of hit on a few things. So who is IATA? IATA is the International Air Transport Association, and they put together the specific guidelines for shipping hazardous materials via air. And it's not just lithium batteries, it's any type of hazardous materials, flammable, corrosive, anything that's hazardous that's going to ship via air. These guys put the guidelines out. And the one thing about them is, and how does that affect OEMs and how does that affect people that ship batteries? Well, any company that ships lithium batteries alone or as part of their end product must have people certified to manage that. It's not just I understand, I fill out the paperwork. You actually have to take a class, you have to pass a test, and then you have to do a recertification exam every year. So it's a significant investment for any company that does manage lithium batteries. The UN DOT 38.3 is a specific test for lithium products that's mandatory to ship any lithium battery product, be it a cell or an assembly, via air shipment. And we'll go into a little bit about what the exact tests are and then specifically what the changes were that just recently came out here further on in the presentation. So why are these changes important and why are these regulations important? Well, there's several reasons. You know, as a member of the flying public and somebody who spends a lot of time on commercial aircraft, I want to make sure, and I'm fully in support of these regulations to make sure that the flying public is safe and that batteries are managed in the proper way. I mean, you don't have to go too far to remember some of the challenges with that Boeing had with their aircraft, with the UPS crash many years ago, and most recently with the controversy over the hoverboards and some of the issues that they're having with their battery power. But secondly, is that the shipper is 100% responsible for compliance. Even if you're not the person filling out the paperwork, manufacturing the product, you are still responsible. So if you have a vendor who you are giving your UPS number to and you are the shipper, you're responsible. So it's really important to understand what the responsibilities of the shipper are, and making sure that they're being followed on that end. And then, honestly, really more from a supply chain perspective, shipment delays and flat-out rejections are becoming commonplace because there's really no gray area any longer. And especially when you're looking at Asia, you're talking about some substantial delays, weeks, many instances, that a shipment will not leave the port if everything isn't completed correctly. So what is the 38.3 testing? Well, it's 8 specific tests to simulate failure modes that a battery pack could see from an environment in flight. And what it really does is it takes the extremes and it puts that actual battery pack through those extremes to make sure that it could survive all of the things that it could see in flight. Some of them are pretty commonplace. Obviously, an altitude simulation test is something that's only going to see in flight. But things like thermal, shock and vibe specifications that they'd have to go through, and then an external short circuit. With those first five tests are done on every single battery cell or battery pack to pass 38.3. With the T6 and the T8, it's only applicable to the primary and secondary cells themselves. So a battery pack itself doesn't need to go through that, but the cells themselves do. And then T7 is the overcharge that is for rechargeable batteries and battery packs only. So a battery pack itself is going to have to go through that overcharge test to become 38.3 certified. So those are really the 8 tests that the battery itself, whether it be a cell or a battery assembly, must go through to pass and become 38.3 approved. So who's created this thing? Well, the UN actually are the ones who are the overseer of the manual of testing criteria for the transport of dangerous goods. And like I said, this is a very lengthy bit of material because it encompasses a lot more than just batteries. But the last 6th revision was issued in 2015, and it's effective in 2017. And it's very easy to get. You can go to the UN website, and you can get it in many different languages. It's a pretty long document. What we're hoping here is to really just identify some of the major things that have changed so that you're aware of them, and if you need to go research them further, you can either come to us or you can look it up for yourself. So what are the 6th revision changes? Well, there's really been 8 of them specifically, and in all honesty, they're not that different from a testing perspective than they are today. It was really identifying and clarifying a lot of different things. One of the real reasons that this was done is because with the dramatic increase in batteries for automobiles and solar cells, larger batteries are now being shipped more often, and there needed to be some specific regulations around those batteries. So again, a lot of these things didn't necessarily change, they just clarified things a lot more. But there were 8 things that actually they went through and addressed. The biggest 2 for us used to be that a component or a cell and a battery assembly were considered different, and there wasn't any real identity as to which regulations a battery assembly had to go through. Well, now they've made that clear that a battery assembly has to go through the same test as the cells do in most instances. So again, the summary for this is that it provided many more definitions, some clarifications, and how the tests were going to be performed. It also differentiated between battery packs and cells, along with getting more guidance on larger packs. One of the things that it did do also is, for many different sizes and capacities of packs, it required different numbers of samples. Not triple or quadruple the amount, but a handful more depending upon the size. So typically it can be anywhere from 17 to 25 packs that you need to submit, and now they're asking you, depending upon the size, to submit more, as you don't want to run the same pack through several different tests, some of which can be destructive if they're done correctly. So for OEMs, what does this really mean? Well, all new designs should be tested to the revision 6 parameters. And in all honesty, if you go to world-class places like Intertech, they're already, you know, at that revision 6 parameters. And your yearly research now also needs to be to the revision 6 parameters, and it may require a few additional packs to allow it to do so, because at the end of the day, whether or not you're certified to revision 6 come January 1st, you're going to have to be. So making sure that you do it as part of just the standard course of action of your yearly recertification is a sound strategy. So this is more of a paperwork and sample size change, as the majority of the designs, especially the ones that we have, would have no problem outperforming the revision 5 or the revision 6 parameters. So we're pretty comfortable about that. At the end of this presentation, I'm going to give you a link to Intertech's website, where they go through and really go through each one of the 8 changes and go down into the nitty-gritty. I think it's a 110 slide presentation where they really get into every single one and what it actually means. And if you're not clear, we're here to help you as well, so you feel free to ask any questions that you'd like. So let's talk about the changes in the IATA shipping regulations, because as we all know, effective April 1st, there were some pretty substantial changes in how we ship lithium batteries, especially by air. And this was really driven by concerns raised in the aviation industry, by the pilots association specifically, and again, in all honesty, I think that it's rightfully so. And as somebody who is in the battery industry, while it creates a little bit more work for us, I think it's more than acceptable to make sure that everybody's safe. I mean, again, I think the bigger issue that really pushed us over the edge was some of the issues that we've had recently with hoverboards. So what are the major changes? Well, there's really 5. And of these 5, we're going to dig down deep into 3. The first one being that no lithium battery pack can be shipped in a state of charge that exceeds 30% of their rated design capacity. And that's going to be a big one. We're going to go talk about that. And secondly, other than very small quantities, nothing can be shipped aboard a passenger aircraft. And that is a pretty big change, because there are a lot of freight brokers that would buy space, open space, on commercial aircraft, and that is no longer going to be an acceptable process. And then from a labeling and packaging requirements, all lithium batteries, especially other than small quantities, must be shipped as a Class 9 dangerous good. And that creates a whole new set of requirements when you're shipping product as well, from a packaging and shipping perspective. So we'll talk about those 3 in a little bit more detail. So the first one is the new Class 9 label for lithium batteries. You know, it was something that wasn't a regulation before, but not only do we have to have a lithium label on the pack, but now Class 9 means it's a whole new set of shipping requirements. If you ship on any one of the domestic carriers and you have a Class 9 package, there's a whole different set of forms you need to fill out to accompany that. And as far as the documentation for batteries, the current rule requires that you have a battery safety document. What you're seeing on the right there is a copy of UPS's document, and all of them really look the same. However, the big change is now is that a lot of the shipping companies have different requirements. Not only do they want this, they're asking for MSDS sheets, which is a sound practice. Some of them even want pictures of the inner packaging so that they know how you packed it inside of that. Maybe even before you ship it, in some instances, they want to see what that looks like. So you really need to understand what each individual shipper wants prior to shipping to avoid any delays, any shipment being rejected. Everybody's seen this matrix where, you know, Section 2 is the real small batteries, and it's the only one that doesn't need the Class 9 label. But as you can see from the quantity, it's only 8 cells or 2 battery packs that have less than 2 grams of lithium content. So it's not very many. And so, you know, for all intent and purposes, right now, every single one is going to have that Class 9 sticker on the box. So now that we have these new labels, you know, the one on the top left is one that everybody's been using for several years now. It's pretty much been a standard practice for lithium batteries, and along with that document that I showed you a couple of slides back. But the one on the right is now a new regulation and a new label that has to be put on there. And that one in the middle, that Class 9 label. And the Class 9 label in the middle is a little bit different. Standard Class 9 on the bottom, where that white, where those batteries are, is usually blank. So you can use that blank Class 9 label on the box. However, it's recommended that you use one that has the actual batteries on it so that it further communicates what the hazard is, because a Class 9 by itself can be many different things. That is regulated by the UN DOT. So from a labeling requirement, now it also requires that you have a box that's big enough, to be able to handle all of these labels, because to pass the UN and the DOT regulations, the labels need to be a certain size, and they're not very small. So the boxes, the outer boxes, need to make sure that they can fit all these labels clearly. So a summary for labeling and documentation. 1, all lithium batteries except for Section 2 must be shipped as Class 9 dangerous goods, and we talked about what some of those additional requirements were. And what does this mean for shippers in the U.S.? Well, we talked about the shipping personnel must be IATA and hazardous materials trained. IATA, they have to be certified, which means they need to pass the test and they need to continue with their yearly certification. Hazardous materials trained means that they have to get with the shipper to make sure that they're trained to ship out Class 9 goods and they know what additional packages are required. 2, when shipping from international ports, each shipping company has a separate location where they accept hazardous materials. So it's not as if you could just have DHL come pick up all packages, and some of them are Class 9 and some of them aren't. There's a separate location where they accept hazardous materials, and a lot of that was driven by the fact that many of these shipping companies weren't comfortable having their existing supply chain bring the packages through. They have to go through a separate group of tests, and so they're going to quarantine them off. So this adds time to shipment, and many times the shippers will limit the number and the amount per flight. So again, it could add time and affect your supply chain pretty dramatically. And the documentation needs to be exact. And not only the company that's shipping should have a procedure, or you need to give them a procedure that tells them how they should do it, because as you're responsible, you need to make sure that they understand what they need to provide and what they need to do to get the shipment to you safely and correctly. Because a lot of times what we're even seeing now, we ship a substantial amount of batteries from Asia, is that there are shipments where the inspecting authorities open every single box to make sure that we're only shipping what we had said. And we do a lot of additional things versus the very minimal, because we want to make sure that the authorities have all the documentation they could possibly want. And even to go as far as, before we make the shipment, we provide the documentation to the shipper so they can approve it, and they say, yes, this should be good to get through the regulatory checks that we're going to have at the port of exit. And again, because you're 100% responsible, it really is in your best interest to make sure that your vendor clearly understands it and has a documented process in place to make sure that they satisfy all of the requirements. The second major change is, again, what we call the state of charge, and it cannot exceed 30% to be shipped via air. And up until this time, most customer specifications have been between 50 and 75% upon receipt, as their process was to get the battery in, put it into their product, and then it would go through tests and right into their end packaging. Unfortunately, that's going to no longer be acceptable. This includes batteries manufactured prior to this date, and what we're seeing now is that if you have inventory, one of the challenges is that finding a way to reduce that state of charge to 30% before shipping. We've worked with a few customers on helping fix that problem as well. It does not apply if the battery is installed or packed with the equipment the battery is intended to power. So if you're inside of a laptop, it doesn't apply. However, as far as packed with the equipment the battery is intended to power, if there's a separate battery depending upon the size, there is a limit to the quantity of batteries that can be in that package. So you can't have a laptop with 5 additional batteries in it. You can have a laptop with 1, but above that is not allowed. And you need to understand what that limit is for your application. And like I said, it creates some new process steps at OEMs, as now they not only have to install the battery, but they need to add a step to get the state of charge up to their desired level for the customers prior to shipment of the entire unit. So how are they enforcing this? Because it's not as if every battery pack or every cell has a fuel gauge on it. You can just go ahead and hit the button and it tells you what it is. Well, currently what we've seen in the U.S. is that it is done at the location of receipt, and people are coming in, enforcement folks are coming in and asking the factory that received it to demonstrate that the state of charge is less than 30%, because obviously people like us, we have the equipment to be able to do that, and so that's the logical place to do it now. But there are a lot of next steps going into effect. Government agencies, especially in China, are ramping up to be able to do it themselves. Some countries are requiring the shipping companies to have the capability of doing the test themselves. And some shipping companies that we work with are even discussing the possibility of them evaluating randomly every shipment prior to packaging it, because they're just wanting to make sure that they're as responsible. And part of what this regulation is going to be looking at over the next several years is making the shipping companies just as responsible as the shipper, and now they're starting to put things in place to protect themselves. And there has even been talk of, not allowing lithium batteries to be flown by aircraft at all. Now, I think that we're a ways off of that, but is that wildly out of the question? I would think at this point the answer is really no, it's not. And so everybody needs to be prepared and make sure that we follow all these regulations. And if we do, I think that we can take away a lot of the dangers that have been put in place so far. So from a packaging perspective, it's interesting because they really didn't do a great job of defining what rigid packaging meant. They say that the updated regulations specify that a strong, rigid outer packaging must be used. And then you have to go in a whole lot further to get the real definition. And what it means is that the completed package must be able to withstand a 1.2 meter drop test. So what that means is a couple things. Obviously the package, you have to be able to demonstrate the package itself can withstand that. The one sure way to do that is to buy UN certified packaging that has been certified by the UN to be able to withstand it. Because if you buy that packaging and it's got that UN marking, as you see on the right here, then it will never be in question as to whether or not that package can survive that drop test. However, if you don't have it on there, your package may well be able to survive the drop test, but it becomes a lot more difficult and it can be questioned and your shipment can be held up. So it's recommended that you use that UN certified packaging with the UN nomenclature on the outside of it to minimize any additional delays. Prototypes, and this is one where we've had a lot of questions on, because when you've got real small quantities of non-38.3 certified product, how do you ship it? Because if you're not able to ship, especially from your manufacturers in Asia, there's no real way for you to test or to understand if that product's going to work. So there is. And one of the things that you'll see in that section 2 is the shipping requirements are even further. To the point we've gone to the extreme, even when we ship ground and it's not 38.3, we will package the battery in small packages. We'll put it inside of a metal drum with vermiculite, and that metal container will go inside of a UN certified box, which is really the mechanism that you should use for shipping prototype quantities that haven't been UN 38.3. But what you have to do to ship small quantities, you have to obtain approval, be a certified shipper. Obviously, everybody wants to protect the cells and batteries from short-circuiting. A lot of time what that means is that if you've got leads that could possibly touch one another, You're going to want to make sure that those are segregated. You want to make sure that you individually pack each of the batteries in an inner packaging with outside packaging. Again, that goes into that outer metal drum and inside of a box. And the amount that you can put into each one of those packages is regulated, like we talked about. 8 cells or 2 batteries if they have less than 2 grams of lithium. So you need to follow those regulations, but obviously it's really difficult to ship product in any quantity that'll be not 38.3 certified. So when you talk about pre-production runs, when you talk about smaller production runs, you're going to need that 38.3 before you can really ship those products here. So it's one thing to really understand what that means. It's another thing to be really qualified and set up to ship those, because looking at the additional cost of even, it's $200 for one of the lithium battery shipping containers, which is why we reuse them a lot, because we want to make sure that everything is safe inside of that container. So as we talked about, Section 2, right, you can go ahead and ship those because it's small without that Class 9 label. And that, again, it saves a little bit of cost, but one of the things it doesn't do is first thing it does is it creates an issue, because they're so used to seeing lithium batteries with that Class 9 on it now, and they're going to be asking a ton of questions. Then you're going to have to prove that you're meeting all those Section 2 requirements. So in many instances, people are just following the regulations for the other, even though that amount is so small. Because if you're following all the regulations and the amount is so small, you're not going to have any delays. So people like us, we've gone and we've said, listen, we're going to go ahead and we're going to label everything as Class 9. We know it costs more, but from a safety perspective, it's well worth the additional investment. So in summary, significant investment must be made to manage the shipping of lithium batteries. Everything from the training, from the certification, from the additional packaging, from even the procedures and the documents that you need to make for every single shipment. It's not just I do it once, it goes on file with somebody. This is on every single shipment that needs to happen. So it's a lot of investment. And it said the shipper on the shipment label is legally responsible. So for anybody who's using your number, it's your responsibility. And the authorities it's going to be easier to come after us U.S. companies than it is to go after people in Asia especially. And shipment delays are wildly commonplace, and especially in Asia, where there has been a trust factor, because there's been an awful lot of folks that it's been exposed as not doing it correctly, and there's going to be a zero tolerance. From what we've seen with the shippers and other governments, it's going to be you make one huge mistake and you're not going to be allowed to ship anymore. And that's going to be a real issue for a lot of companies if that happens. So being diligent, being upfront is really part of what we need to do as an industry to make sure that we're following all these regulations. And there are many more details to review. Documents out there. I just listed a couple of them here. The first 2 are really just excerpts from that whole IATA guideline that just talked about lithium batteries. And the last one is from Intertek. And Intertek is a world-class company when it comes to the 38.3 testing, and they have a in-depth going through of every one of the changes in the 8 tests. And we've been able to develop a lot of this documentation through the experience that we've had with a lot of our technical partners. The Battery Council especially, they do a lot of work with the regulators, and they keep all of us as manufacturers up to speed. A lot of our manufacturers, like Panasonic, Sanyo, Boston Power, have been really at the forefront of making sure that we as an organization are up to speed on all the regulations. So with that, we've got some questions, and I'm just going to go ahead and pick a couple here that will come through. And somebody threw up an easy one here first. It says, how much and how long does UNDOT 38.3 take? Well, it really depends upon the size of the battery pack, but there are some basic guidelines. It usually takes about 4 to 5 weeks. Like we had talked about, it's 17 to 20 to 25 packs, depending upon the size. and it runs anywhere from $1,300 to $3,000, and there is a yearly fee you have to pay and a yearly submission that you have to pay as well. So it's not that costly, to be honest with you. So it's really, from what this does as an industry, as you can see, it's not that costly, it's that time consuming. And it's very clear as to what you need to be able to do to build the robust design to make sure that you're going to pass the 38.3 tests. The second one is, if the pack is UL certified, does it still need to go through 38.3? It's a good question, and yes, it does. UL's test is much more stringent than the 38.3, and many of the same tests are being done by UL. However, the IATA test is specifically around air transport and the specific extreme parameters that it can encounter while on air transport. So yes, while it is more stringent, you have to do both. And the last one here is that, can I have a pack that does not have 38.3? The answer to that is yes. And the only real difference is that you have to choose your transport modes without air transport. So if you transport solely via sea freight from Asia or from Europe, that's great. If you can ship via ground transportation in the U.S., you don't need that 38.3. However, it's very inexpensive and it's well worth the time, and we don't recommend it. It's just very, it's another set of eyes looking at a design that helps make sure that we're following all of the proper safety requirements. So thank you for your time. Again, if you have additional questions that you haven't put in here, please feel free to reach out to us, and we're going to be happy to answer them as quickly as we can. And the ones that have already come in, we'll make sure that we get back to you here in the next week or so. Thank you again, and we look forward to having you on the many additional webinars that we do throughout the year.